Hello, welcome to this video. This video is for Accelerated Math 3. We're talking about inverses today. How do you find an inverse from symbolic form? And what we're going to do in this lesson 4-2, we're going to show you how to calculate the inverse for three different types of function. We're going to deal with linear functions, right? X to the first. We'll deal with quadratic functions, x to the second, and cubic functions, x to the third, okay? And we're going to talk about the inverse functions and how you find them. I'm going to split it into three videos, and we'll just focus on one type of function and its inverse in each one, okay? So for this video, part A, I'm going to focus on linear functions and their inverse. So without any further ado, we'll go ahead and get to it. The first idea I want to draw back to the last video is how do we find an inverse of a function? And it's plain and simple. I wrote it right up here. I don't know if you can see this right here. Okay, how do you find an inverse? You switch your x and y. That's what you need to know. This is muy importante, my favorite Spanish phrase, muy importante. Okay, put an exclamation next to that. You got to know that. Okay, and another idea is, so if I'm going to switch x and y's, okay, and I'm doing it for a function, now how many possibilities are there? Can I do it for every single x and y? Well, that's kind of crazy because there's infinite amount of x's that I can plug in here. Now, later on when we get into to square root functions, we'll talk about restrictions and limiting our domain, but there's an infinite amount of possibilities. So if I want to do this for symbolic form, and again, right here where it says symbolic form, if you're like, what the heck is symbolic form? Well, symbolic form is just an equation written algebraically. Okay, that's symbolic form. Okay, you have different forms of a function. You can see it visually, you can see it numerically with numbers, x and y coordinates. This is symbolically. Okay, so what are we going to do in this lesson? Well, here is the step process. Okay, so first thing I want to talk about is the inverse of a linear function is a linear function. A linear function can undo a linear function. And the domain of the linear functions is all real numbers. I can plug in any x from negative infinity to positive infinity. I don't have to worry about any types of restrictions. Okay, so what are the steps we're going to do? Step 1. Change the function notation to y, and all this is in this step is I'm going to take f of x, so if I have a function, or g of x, whatever its name is, and we're going to switch to y. Now the reason for this is step 2. Step 2, switch your x and your y values. That's it. Step 3, solve algebraically. You just want to solve it. Okay, and then step 4, we're going to change the y variable back to inverse notation. And remember, inverse notation, if our function was f of x, this is f inverse of x. Say it with me, f inverse of x, right? Okay, f inverse of x. Okay, all right, so let's go ahead and look at some examples. Here is the first one, and we're asked, find the inverse of each function, state the domain of the inverse in set notation. Okay, so step 1, I want to find the inverse. I gotta switch some x's and y's, so I gotta have some y's. Huh? Be wise? No? Lame? Okay. So y equals negative 3x. Step 2, I'm gonna go ahead, I'm gonna switch my x and my y. Watch closely. X equals, okay, it was y, equals negative 3. Y. I switched x and y. That's it. All right, step 3. Solve for y. Okay, so I want to go ahead, I want to isolate y, so I'm going to divide each side by negative 3, divide by negative 3, and now we get y is equal to negative 1/3 x. Okay, that's almost it. We're almost there. Step 4, change it to function notation. So this was f of x, so this is going to be called f inverse of x. The function that undoes this function is negative 1/3 x. Same idea, right? When we asked you in Math 1 or foundational algebra, how do you undo multiplication? Division. How do you undo addition? Subtraction. It's the same idea. They undo each other. Example 2. Oh, sorry. Woo! I almost forgot the second piece here. So that's part, it's kind of like the first part. Part A. So here's your part A. Part B, state the domain of the inverse in set notation. Okay, and for linear functions, right, we said that the domain is all real values. So this is a linear function. So my domain in set notation, set brackets, is the x values such that, that's what that bar means, such that x is between negative infinity and infinity. Okay. And there you go. All right, next example. Find the inverse of this function, state the domain. So again, I'm gonna go ahead and I'm gonna make it y is equal to 2/3 x plus 4. Okay, that's step 1. Step 2, I'm gonna switch x and y. X is equal to 2/3 x plus 4. Some people will ask, Schoberg, can I just skip straight to step 2? Sure, if you can do that, right? The y and then switching the x and the y, feel free to do that. But clearly I can't, right? This x is not supposed to be x. That's supposed to be y. Okay, so x equals 2/3 y plus 4. Step 3, now we want to solve for y. So if you ever get stuck here, if you ever forget to isolate y, you're doing order of operations in reverse order. So we're going to undo addition, subtraction. Okay, so we get x minus 4 is equal to 2/3 y. Now I want to isolate my y. So we'll multiply both sides by the reciprocal of the fraction. That's how you cancel fractions, right? I'm undoing division, so I multiply. I'm undoing multiplication, so I divide. Okay, and we have y is equal to 3/2. Whoa, look at that, that's cool. 3/2 x, okay, minus 4 times 3/2. So 3/2 times 4 over 1. Okay, and we just get 3/2 x minus, this is going to be 12 over 2, so that's 6, minus 6, okay? This is almost our answer, step 4. We want this to be in inverse notation. So our function is called g, so what do you think our inverse function is going to be called? G, inverse of x. G, I wonder, okay? So there's your inverse notation. Again, the last part, we need to state the domain. So the domain of our inverse is going to be the x values such that negative infinity is less than x, which is less than positive infinity. Another way of saying this is all real numbers. All real numbers, okay? The problem wants it in set notation, so yes, you have to do it this way, okay? But it's the same thing as all real numbers. All right, so those are the 2 examples. I have a practice problem here for you. I would like you to pause it, do it. Did you state the domain? Okay, pause it, try it, and I'll post the answer here in a second. All right, so here's the solution. Okay, f inverse of x is equal to 1/2 x plus 4. Did you get it? Good job. So proud of you. Okay, domain, and then here is the second one. Next example. Okay, and here's the solution. All right, so in this video, we talked about finding inverses of linear functions. The inverse of a linear function is a linear function, and right, domain is all real values. You can plug anything into linear functions, anything from negative infinity to positive infinity. Okay, so again, here are the steps, and before we get to the steps, I want to focus on what type of inverse function. If I have a quadratic, what is the inverse going to be? And I'll go ahead and I'll draw, if I can find my ink. Okay, so here I have x squared. So here's a quadratic function. Now, how do you undo a square raised to a power of 2? Well, you take the square root, right? So to undo it, you take the square root of whatever that value is. Okay, so the inverse of a quadratic is a square root function. Now, in order to make a inverse, a function specifically for a quadratic, what we have to do is we have to place restrictions on our domain and our range. So when we take the inverse, it is a inverse and it passes that vertical line test like we talked about in the previous lesson. Okay, so we'll go ahead and do that in step 4. So again, just to recap the steps in general, step 1, change the function notation to y. You got to go from f of x or g of x, make it into a multivariable equation. After we've done that, remember, how do I find the inverse? Switch your x and your y, right? That's step 2, switch your x and y. Here's your kind of the main key idea about inverses. Then step 3, you're going to use algebra to solve for the y variable. Okay, and this is important. When you use the square root property, so when I take the square root, okay, we are only going to use the principal square root. Now, what the heck does that mean? Well, when I take the square root of, say, for example, 4, I know that this answer is plus or minus 2. Okay, well, we're only going to take the principal square root, the positive value, and I'll put it in green, positive, okay? This will make an inverse function. All right, so second, or after that, 4th step, determine the restricted domain. This limits the range values to the set of real numbers, okay? So we'll only focus on that specific domain. And then step 5, rewrite the y variable using inverse notation, and we'll write that restricted domain. Okay, so without further ado, here is our first example. We are asked to find the inverse of f of x and state the domain. Okay, step 1. I'm going to go ahead and I'm going to change from function notation to multivariable, right? X's and y's. Now, why am I doing this? That is because step 2, you have to switch your x and your y. X is equal to y minus 4 quantity squared plus 3. All right, now I'm going to go ahead and I'm going to solve. That's step 3. Again, if you forgot, just use order of operations backwards. I'm going to undo the order of operations. So addition, subtraction, I'm going to subtract 3 on both sides. Okay, and we get x minus 3 is equal to y minus 4 quantity squared. All right, now I want to undo the square. So I'm going to take the square root, take the square root. We get the square root of x minus 3 is equal to y minus 4. Now normally, right, when we take the square root here, we would have plus or minus, but we're only going to focus on the positive value. Okay, so square root of x minus 3, and now to isolate y, we will add 4. Now, does the 4 get to go inside the square root? No, it does not. It stays on the outside. I'm not taking the square root of that 4. I'm adding on 4 after the fact. Okay, so do not merge these values. So it's the square root of x minus 3 plus 4 on the outside. This is equal to y. Okay, so which is going to bring me up here to step 4. And step 4 is determining your restricted domain. Okay, so my restricted domain. Now, I do not want imaginary values put out of my function. Okay, so what I'm going to go ahead and do is I need to take my radicand. Okay, and in this case, that's x minus 3 radicand. Okay, and I'm going to set it greater than or equal to 0. If my radicand, the values going inside my square root are less than 0, then I get imaginary outputs, right? The square root of a negative value is an imaginary number. We're not in make-believe land here. Okay, Accelerated Math 3, we keep it real. So we're going to get rid of all those negative values. X must be greater than or equal to negative 3. Okay, well, how do I solve this? I'm going to add 3 to both sides. And we get x must be greater than or equal to 3. Okay, so that's my restricted domain. Schwarberg, what about the 4 tacked on the end? I don't care. What about if I'm multiplying by a 2 out here? I don't care. All that matters is the radicand. Whatever is underneath the square root. Some people call it house. What's in the house? Okay, that's all that matters. All right, so there's your restricted domain. And then step 5, we'll write our final response. Here is our inverse function. This function is named f. So f inverse of x is equal to the square root of x minus 3 plus 4, and then our restricted domain are our x values such that x is greater than or equal to 3. Must be greater than or equal to 3. Okay, there's your answer. All right. Second example, x squared minus 2. Okay, so I'll switch to multivariable. Y is equal to x squared minus 2, and then I'll switch my x's and my y's. X is equal to y squared minus 2. Okay, I'll add 2 to both sides. X plus 2 is equal to y squared. Okay, I want to isolate y, so I'm going to take the square root of both sides. X plus 2 is equal to y. All right, so there is my inverse function. I need to make it a function, but first I need to find my restricted domain. Okay, so again, why do we have restricted domain for these types of functions? Well, it has to do with the square root. Okay, your square root function, the radicand, or the quantity that you put inside your square root, must be positive or 0. You can have 0, right? Square root of 0 is 0, but it can't be negative. If it's negative, then you get imaginary values. So I take x plus 2, my radicand. Can you say that? Radicand. Hey, Lonnie. Okay, and you are going to set it greater than or equal to 0. So we solve x must be greater than or equal to negative 2. Cool. What does that mean? Well, it means that our function named d of x, okay, so is going to be called d inverse of x, which is equal to the square root of x plus 2, and our domain will be x must be greater than or equal to negative 2. Greater than or equal to. All right, so I'm going to go ahead and give you guys a practice problem. Here you go, x plus 5 raised to the power of 2. Please find the inverse, state the domain of the inverse in set notation. I'll pause the video now, and I'll show you the answers in a second. Okay, so hopefully you have found the inverse, and this is what you should have got. Square root of x minus 5, and x must be greater than or equal to 0. Why is it greater than or equal to 0? Well, again, what is your radicand? It's just x. So I set this greater than or equal to 0, and I solve. Hey, I don't have much to do. It just can't be negative. It can be 0. It can be positive. That's cool. Okay, next example. Please go ahead, pause the video, try this example, and then check the answers here. Okay, here are your answers. Did you get it? All right, one more. Here you go, last example for quadratics. Okay, hopefully you found the answer, and here is the solution. Okay. All right, so that is it for this video on quadratic functions and their inverse, which is a square root, right? The quadratic, that's power of 2, okay? How do you undo a raised to a power of 2? You take the square root, okay? Now, when you have a square root, you have to watch out for imaginary outputs. So when we take a function, we limit, right, our input for that domain. All right, that right, meow, are posted here, and they're exactly the same as the first 2 videos, but you'll notice in step 4, we don't have, or sorry, our old step 4, finding the restricted domain, isn't present. This is because there are no restrictions. No restrictions are needed to make an inverse function for a cubic function and a cubic root function, okay? We don't have to worry about it. So all real numbers is going to be our domain, just like linear functions. Oh, that's nice. I don't have to worry about restrictions. Okay, just some other things of note here. Again, and I said this in the intro, is that a cubic function has an inverse, which is a cube root. function. Okay, those are the inverse. So again, just to recap, what we're going to do, we're going to change our function notation to y. We'll switch our x's and y's. We'll solve with algebra, and we'll rewrite in function notation. Without further ado, here is our first example. All right, so we want to find the inverse of this function, and we're going to state the domain in set notation. So again, the very first thing we want to do, change the function notation to y. Y is equal to 0.25x to the power of 3. I'm going to switch my x's and y's. X is equal to 0.25 y to the power of 3. Okay, so now what I want to do is I want to go ahead and I'm going to divide both sides by 0.25. I'm going to divide this side by 0.25, and we get x divided by 0.25 is equal to y cubed. Okay, got to solve for y. How do I do that? Well, you take the cubic root. I'm going to take the root, and notice the index on this radical is 3. Okay, so that just means we're taking the third root. Okay, so we get y is equal to the cubic root of x divided by 0.25, and this is our inverse function. F inverse of x is equal to the cubic root of x divided by 0.25. Okay, and domain, are there any restrictions on domain? The answer is no, there aren't. Our domain is all real numbers, negative infinity to infinity and beyond. Okay, so that is our domain. Here's our inverse. Now, the other thing I want to talk about this problem, maybe that x being divided by 0.25 is kind of bugging you. It would bug me when I get to this step here. I'm going to rewrite this. X is equal to 1/4 of y cubed, right? Isn't a quarter worth 25 cents? Oh, yes, it is. Okay, so how do you undo dividing by 4 or multiplying by a fourth? Well, you multiply by 4. Multiply by 4. Okay, so I get 4x is equal to y cubed, which means y is going to be equal to the cubic root of 4x. So maybe you think this is prettier. I think it's prettier. I would prefer it like this. Are you gonna dock us on the test if we don't have that? No, I'll just look at you and say you should have this, but this would give you full credit. That's 100% correct. Okay? All right. Next example. Here we go. Find the inverse of the function d of x is equal to 2x cubed plus 10, and we're asked to state the domain of the inverse in set notation. All right, well, I'm going to change from function notation. Y is equal to 2x cubed plus 10. Okay, now I have multivariables. How do you find the inverse? Switch your x and your y. Switch it up. Switch it up. Okay, so 2y cubed plus 10. Okay, now I want to solve. There's a lot going on here, and people often make mistakes in undoing or isolating a variable. So here's PEMDAS. Again, if you're undoing stuff, you work backwards. So I'm going to subtract 10 on both sides. X minus 10 is equal to 2y cubed. Okay, now how do I isolate my y? Well, you got to get rid of the 2 first, right? Undo multiplication division, so you're going to divide both sides by 2. This one I will show you the inverse operation. I'm going to divide everything by 2. What you do to one side, you must do to the other side. A lot of people just kind of think only one thing gets affected by that 2. Okay, so what we have is 1/2 x minus 5 is equal to y cubed. Okay, what's next? Well, you got to undo your exponent. So I'm going to take the cubic root. Root, take cubic. Okay, cubic root. All right, so what is my answer? I'm going to come up here. Okay, y is equal to the cubic root of 1/2 of x minus 5. Now I want this to be an inverse function, so you have to change to function notation, right? They say function, they don't say equation. They want a function, so put it in a function. Cubic root. Yes, I will dock you on the test if you don't do it. No, I don't care. Okay, so do it. All right, And then domain. They're x's. Okay, what's possible? Anything from negative infinity to infinity, as long as it's real, right? We don't play. Okay, there is your function. I'm getting loopy. Okay, so here's a practice problem. I'd like you to pause the video. Pause it. If you have any questions, write them down so you can ask me when you get into class. Okay, and here are the answers. Pause it. Do it. Did you do it? Good. Here it is. All right. So there's our inverse. And again, notice domain, all real values from negative infinity to infinity and beyond. And here is the last practice one. 2x cubed plus 4. And here's our solutions. All right, so hopefully you got this these problems right. Hopefully you feel good about it. The problems really for all of them are the same, this approach, I should say. And the only one that's different is when we have a power of 2, we're going to have to go ahead and state that restricted domain, right? We can't have negative values in the square root. And when we take the square root, we're only going to take the principal, the positive values. All right, so hopefully you like these videos. We've talked about how to find the inverse. You switch your x and your y. Solve for y. That's it. All right, I'll catch you next time. Work hard, be easy, be chill. See ya.